Math and Machine Learning Using .NET with Mathias Brandewinder.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, deliver quality, and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a software architecture company that empowers .NET teams to be self-sufficient and able to deliver world-class results. And they are hiring architects and .NET engineers who'd like a path to become an architect. So you can go to clearmeasure.com/careers for that. And if you have a comment or question for the show, send me an email at podcast@palermo.network. And last episode, I announced Programming with Palermo, the new online TV show that's syndicated everywhere. You can get podcasts and YouTube and everywhere. So that is new, and I encourage you to go check it out. You can also find the links there at www.palermo.network and check it out. Send me an email as well and tell me what you'd like to see on that. But let's get into this episode of the Azure DevOps Podcast. I have with me Mathias Brandewinder, and he enjoys solving challenging business problems with software engineering and applied mathematics techniques and some creativity. His current focus is on functional programming with F#, machine learning and data science, and on putting them together to help companies make smarter decisions with their data. He loves teaching and mentoring, and is a regular speaker at conferences and community events all over the world. A former F# MVP also, and he holds a Master's of Science in Operations Research from Stanford, an MS in Economics from University of Paris X, and an MBA from ESSEC. So Mathias, welcome to the show. How are you, sir?
I am doing very good. Thanks for having me, Jeffrey.
Oh, my pleasure, my pleasure. I was enjoying talking about math. And so you've had a huge background in math, and you're a former F# MVP. I think I've met a few of those, and always fascinated by the take that F# takes, different from C# and different from different .NET applications. But before we kind of dig in, I always like to ask the guests, you've done so much. What are the key parts of your background that you think have kind of steered you in the direction where you find yourself doing the work that you do today?
That's a great question. So if I think about how I landed where I am today, a lot of it was accidents. As you mentioned, is I have a big interest in math, and pleased me and caught me by surprise that you would too, because most people just start to back away from you when you say you're into math. So I didn't plan to be a software engineer. My original plan was I wanted to teach. And I was very much into math, and specifically into applied math. The part I really enjoy about it is when you see an actual problem and you try to fit what pieces of math can help you out and how you can actually solve it by being a bit clever. And I wanted to teach that type of topic. And then after I graduated, I actually found a job which was with a consulting company where my job was to design models in the mathematical sense, doing not really coding. And of course, what happened is people did bigger and bigger models. And so I needed tools. And so I decided perhaps Excel was not the best way to solve everything. And so I started to look into this thing which had just come out, which was C#. And I got lucky to have a colleague who was really good at C# and who showed me the ropes. And so I plugged along and wrote a lot of quantitative models in C#. And that was my life for a while. And then I think around 2010, F# came out. At the time, I thought I was a decent developer. I thought I knew what I was doing. I was young and foolish back then. And then there was this F# thing, and I thought, it looks pretty different. I had also read this advice that a good way to get better is to look at other programming languages. And so I thought, that's a great opportunity. Let me take a look at it. And this was terrible. It was really interesting because pretty much none of what I knew about C# helped. I was like I was fighting the language tooth and nails because I was trying to do things a certain way. And so I took a step back and thought, let me just like forget about what I do from C# and try to write in the style that the language is suggesting. And like it took like 2, 3, 4 months. And at some point it started to click. And I kind of never looked back. So I've been doing like F# like initially as a hobby, and now that's pretty much my main tool. And this was, that's what I do now. So this is how I ended up in the current place.
Oh, fantastic. So C#, when C# came out, I think I dabbled around with it when it first came out too, 2002-ish, somewhere around there, 2003. And then what intrigued you about F# that you decided, that you went really deep into F#?
Part of it is obstination. Part of it is like it worked. Like the initial part was I hate it when people show me something and I don't understand it. And so there was this tension for me, which is I thought I knew how to program. I saw that people are considered very smart were really speaking highly about the language. And I couldn't get it to work. And so that's the best way for me to get started on something is like when you give me a problem and I don't know how to solve it, is like I will go hard. So I started with it like out of a sheer obstination, like I wanted to understand what this was about. Mm-hmm. So that was really the starting point. Like otherwise afterwards, like the part which really caught me, there is one piece which is over time I got like more effective, and I thought like it was just a much faster way for me to express the type of things I was trying to express. Like at some point, it's like the writing the code I wanted to write was just faster. Mm-hmm. A specific piece which was interesting to me, which was totally new for me coming from C# was the scripting environment. And that's like not super important for most people. Like most of what I had seen on the C# side was people going to LinkPad. Mm-hmm. Which is a typical type of use case. Is like you want to do something, you're not quite ready yet to write production code, you don't really have a domain, is like you just want to tinker with the data and like write code and see how it plays out. And but that was pretty marginal on the C# side. And like as it turns out, is like I do a lot of work with data or like building numeric models. And the F# has a pretty good scripting environment. And so that's one thing which really caught me because it's making it very easy to work in that type of like a rapid environment where you just flesh out an idea, sketch it out, see what works, what doesn't, and work with the data. So that was a big part of why I got interested.
Okay.
And now I've kept going a bit, like the scripting environment is what it is, but the .NET has added better support for Jupyter notebooks and now the .NET notebooks. And so that's in the same direction. And that's one piece which worked really well for me. And I think F# is in general, I would argue like a better scripting language than C#. Like it is just much lighter syntax-wise. So like it works really, really well in the scripting environment.
Yeah. I'll admit, I haven't personally gone deep in F#, but when it comes to the whole space of just functional programming and then of course working with numbers lends into that, I often still encounter situations where a computer's version of a number doesn't really line up with the math version of a number. That strikes me. Do you think about that much?
I do. Yeah, it's an interesting case because nothing is simpler than an integer. Mm-hmm. And yet, it's like if you take an int 32 or an int 64, it's not what people mean in the math world with an integer. Like an integer, by definition, has like always a successor, right? It's like there is always another integer later, and it's like that's not what happens if you go to the int like max number or something, add one, and you're going to get back to minus. So there is a discrepancy. I think it's interesting too because there is a train of thought in like maybe some functional people that code should be like math. I don't really fully agree. It's like I think it is different, and you have to accept that it's not the same first. And it's like I'm not trying to write like provable math programs. The part where I find like math similar to coding maybe is like I feel like debugging is very similar to writing a proof, and that you tinker, right? It's like it's not like you know exactly what the flow is. You try, you eliminate things which won't work. So it's more akin to cooking a dish than doing abstractions. So yeah, like I think math in the computer and math are not quite the same thing. And yes, like numbers are like widely different.
And that's not a new problem either. Well, I mean, .NET kind of came out with int64 was the default, but before that, int32 is the default. Before that, int16 seemed to be the default, at least in Windows programming, which tops out at 32,000 something. Yep. But we need numbers larger than that.
it's definitely not all the numbers. Yep.
Right. And the databases as well. I was recently coaching a younger developer, and I had to, do the lesson over again about just how to store currency in a database, then how to work with it in programming, and then how to display it on a screen and then go back and forth, because a double or a single is not the same as a two-place decimal, which our money system relies on.
Floats and doubles and are like another corner of hell. Like all the rounding issues are like, it's the type of thing where you look at it, a friend tells you about it, and like it looks like, how hard could it be? Like it's a stupid problem, and then you start to dig into it, and it's like it's ridiculously complex. Even like the case about integers is like it's quite. You were talking about databases. Like a friend of mine was telling me recently how they had like indexes which were like integers, and sure enough, they are running out of integers. Which should not happen. Like but yeah, rounding is tricky, and like that rounding, like numeric rounding errors are like a huge problem. Is like especially like in machine learning and computation too, because then you have all these issues where things get close to zero, and as like you get all sorts of rounding and propagation of errors. So yeah, it's own special corner of hell.
Yeah. Now, does F# make those issues any easier than C#?
I would say they do not, because in the end, F# is a .NET language. So the float I'm using or the numbers I'm using are the same like that the C# developer is using. So from that standpoint, is that you get the same problems. Like there is a type, I don't think it's actually a .NET type in general, but there is a type which is like a big integer, which was sort of helpful for like if you want integers which are going to be as big as you want, but then it's like you get into performance issues as well. Yeah. But like otherwise, it's like it's not better. Like from a numeric standpoint, the numbers themselves don't really help. There are a couple of things where F# helps. One of them is something called units of measure. I don't know if you've encountered them, but like these are really, really nice. So what units of measure in a nutshell are, it's like the traditional problem of like, are you talking about a mile or a kilometer? And that's a problem which you will get if like your method, like your code is working with the floats, and there's like you get something which is a get distance, and what you get is a float. And then there's a good luck to figure out if you're talking about meters, kilometers, mile, inches. So you don't really have a unit. And you can solve that by like putting some wrappers around it, like a money type, like whatever, something like this. But it's not super fun to do on the C# side. So F# has this thing called units of measure, which are essentially like annotations you can put, and you can say like this number is going to be a number with a unit attached to it.
Oh, nice.
And then you can do things like if you have, for instance, a method which returns a meter and a method which returns a mile, you cannot sum them together. Like it will tell you it doesn't work. Like you have to have consistent units. It will do nice things. Like if you multiply 2 miles together, you're going to get square miles. So they compose together. And as an extra bonus is like they are really interesting because they are like attributes on it. It's helping at compile time. So if you have any inconsistencies in your measures, it will tell you like I can't compile, but otherwise they are erased once it's compiled. So you get like all the benefits of working with raw floats, raw ints, like raw types, but like you get extra safety at compile time. And it's something which has been like saving my life. Like lately, I've been doing a lot of things with manufacturing. And so I have problems like optimizing production on the production lines. And so I have a lot of things like the rate of this machine is like 27 cartons per second. Okay. The cost is like, I don't know, $20 per kilogram. And so it's really, really, really easy to get lost into what the hell is this number. Right. And so that's been really saving my my bacon like a lot of times, like just being able to put units. And it's literally free because like all you have to do is to say like that particular field is going to be an int annotated as like cartons per minute, and then it's like everything flows through, and it's going to tell you where you have inconsistencies.
Interesting. In order to make use of that, does your executable code have to be F#, or are those libraries in NuGet that can be used from any NuGet, any .NET language?
So as far as I know, it's available only if you write F# code. So you can write that in your F# code. On the other hand, once it's compiled, it's like everything will look like the raw type.
Yeah. Okay. So
it's really just doing like a safety check before you compile, and once it's verified, it's like the units disappear.
Okay. Yeah, that's all over the place. You're right. We have a variable value, but then the question is, okay, what unit is this in?
Yeah, or like a problem I had a lot of times is things like you got 0.8, it's supposed to be a percent. Do you mean 0.08% or like 80%, that type of thing?
Right. Yeah, normalizing it.
So this is like a really cheap way. So nothing will save you from the fact that integers can overflow and all of that. But on the other hand, is like you get that type of safety, which is really, really nice and pretty cheap to implement.
Nice. Speaking of making sense of numbers, earlier this year, I really enjoyed one of your blog posts where you talk about charting types with plotly.net. Just out of curiosity, is that your favorite charting component, or do you have a handful of favorite charting components for .net?
I've been going over a few ones over the time, but at the moment, I would say it's my favorite. Like the Plotly is like surprisingly complete. It has like a very big depth of charts. You can use it with minimum effort from the web, from a .NET application directly. So yeah, at that point, it's my go-to tool. Works also really nicely in the scripting environment.
Yeah, and it looks like it has a lot of interesting visualizations.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
Yes, you can get like the standards. Yeah, you get the standards like your bar charts, your column charts, all of that. But like recently, I ended up using it on a project for things like geographic visualization. That worked like pretty well. Like the blog post you're talking about, I think is like I have like some which are like much more exotic, but it goes pretty deep.
Yeah. One of the things that I find, again, with just coaching younger developers that seems to slip through the computer science curriculum is making charts, and then you dig into it and realize that the numbers fed to the charts aren't the same thing. Like we want to do how much revenue came in from sales over the 12 months of the year. And so then you have a line graph and you're like, wait a minute, we didn't change anything. Why is the line graph wiggly? And then you realize, because the months aren't the same size.
Yeah. Which is also the part where like a chart, I'm happy to have a library like Plotly, because a lot of times like the data numbers there is no better way to figure out that you have a problem in your data than getting a quick chart out. Yeah. So you get like that problem, but it's a really good way to spot like if something is really awfully wrong.
Right. Well, that's really interesting. There's so many charting libraries that are heavy in HTML or heavy in JavaScript, but this one, all the API looks to be really nice, strongly typed .NET.
Yes, the team behind it did a really good job. Plotly, I believe, is originally a Python project. So but the .NET wrapper is now, I believe, part of the Plotly ecosystem. Has been accepted, and it looks also like the API both from F# and C# are pretty nice. A real effort has been made so that it's palatable.
Yeah, and now this is, I guess, a number of years back now, but I want to just touch on your book from a number of years back, Machine Learning Projects for .NET Developers. That's over 300 pages. That's a significant book. Before we kind of dig into it, what made you inspired to write that? And are you thinking of a next book?
So first, I'm thinking of a next book, and part of it is I would actually love to take back the content of that book and update it maybe, because it was written far enough in the past that things have changed. For instance, there is such a thing as .NET Core. Many things have evolved, and I would write a few things differently today. But the motivation for this was a big part of it was the same motivation I have for giving talks and writing blog posts, which is the best way to understand a topic is to have to explain it to somebody else. There is a surface knowledge where you write code, you use things, and you kind of think you know how it works, but it's easy to gloss over the details. And when you have to give a talk or present the material to other people, is when you're really starting to dig deep, in part just because you're terrified that somebody will ask you about the topic and you won't be able to answer. And so like the origin of this was a double. Is like one of them was my background is in applied math and in optimization, and I got interested in machine learning, which is very similar to optimization. And so part of it was my learning process, going from my background in optimization and trying to map it what people were doing in machine learning. And so I had like a lot of blog posts, and at some point it was like maybe there's so many blog posts and there is enough interest that I should make that into a book. The other piece was related to I'm still going back to like you being one of the few people who enjoy math, because one thing which makes me sad is like how few people actually enjoy math. And like it's probably an indictment on the way it's taught, because math can be genuinely fun. And machine learning has that similar type of aspect, which is it's a bit of detective work. It's like you have data, you're trying to make something work, and so there is a bit of tinkering. And I wanted to write something which was not how do you use that library and don't think about it, but just plug it in, but like more like take a problem and try to figure out like what is it that a machine learning does and build it from scratch. So that's what I did. Is like I took like a bunch of classic algorithms and just wrote them from zero, from the ground up, because that's the best way to understand what's actually going on, in my opinion. One good way to evaluate libraries or a problem is like just try to write your framework for it, and then it will give you a much better appreciation for like what can go wrong. Why did people choose to design it that way? So like do it yourself, try it and see how it goes. And so that was the source of the book. Like do something playful where like you take the data, take the ideas and like try to build it up from the ground and see what you learn along the path.
Gotcha. You mentioned you're wanting to do an updated edition. What does a machine learning project look like in .NET 6? What are the big differences?
Well, like one difference I would bring up is the existence of notebooks. I think that has changed things quite a bit, because the notebooks are a really good fit, at least for the part which people would put more in the bucket of data science. Because a lot of times it's like what you have is data and you're trying to find patterns. There's just so much data that you can't really deal with it that way. And so being able to write a bit of code and then produce a chart right in the same place without having to jump through hoops is important. So notebooks have made like big strides in .NET since the dark ages when I was writing before. Otherwise, like there are also like new libraries out there. So one of them is like ML.NET. So I'm not sure I love ML.NET, but that's something which didn't quite exist back then. And the other library which has been which I'm currently looking into, which is really interesting, is a library called DiffShop.
DiffShop, is that what you said?
DiffShop. Yeah.
Okay.
So DiffShop is a library which does what people call automatic differentiation. And so what automatic differentiation is like, so it's a niche topic in the sense of like only people who care about computing derivatives will care about this, but like that covers a lot of people in machine learning. So what DiffShop does is like you can essentially write a function in FShop, like code which describes what the function does, like just like you would write a method. And then you can take that method and you can say, can you please give me the derivative? And that's what DiffShop does. And so that's extremely useful, because then you can do gradient descent, you can do all sorts of optimizations. And that's the type of thing which is extremely painful to do by hand. And I'm looking at the current version because it's also supporting the PyTorch backend. So it's been written to one, it does like a lot of dark magic. But if you think about it, like producing the derivative of like any arbitrary function, which is already runnable code in .NET, is like pretty impressive. But on top of that, is if I can get like GPU accelerated, the same thing GPU accelerated, is like I'm in. So now that's one thing I'm looking at right now, which is super exciting.
Oh wow! And glanced at it, it looks like it supports the Jupyter UI as well.
Yeah, that's when, in general, like that's where the Jupyter notebooks and like the .NET notebooks have been really nice, because now is like you can pretty much use like any .NET in these notebooks. So you can even mix and match, which is something which still blows my mind. In the .NET notebooks, you can have like a cell in C#, a cell in FShop, and like have them talk to each other, which is pretty crazy.
I've had another guest talking about Jupyter notebooks just in the frame of learning .NET or playing around with Azure, but we've only scratched the surface on Jupyter. Effectively, it appears to be a on-the-fly evaluator of code that just runs on a server somewhere through the browser.
That's correct. Like the notebooks run a kernel, and one piece is like it's a read evaluate loop, like it's a REPL. So it's like you can write code, run it, and like if you don't like it, change it and run it. So from that standpoint, it's not that different from LinkPad, except that you can run whatever you want. It's much broader. The kernels like come in multiple languages, so you can pretty much run whatever you want here. And the other take on it is the fact it's another take on literate programming. As in, like the thing which is tricky with a code file is code files are great for code. They are not great if what you want to do is an experimentation which you might want to share with somebody. So you have like maybe a text explanation of like, this is what I was trying to do, then a bit of code, and then a chart showing the result. In a project or like in a .NET project, that's something which is not very convenient. A notebook is nice because it's a pretty lightweight program where you can give the notebook to somebody else. They can run it. They can change the code if they want to, run the cells and see the chart update. So it's really, really nice it has a really good space, which is a bit similar to what a lot of people would be doing with Excel. Like I can send you an Excel file. You have the code, the numbers, the charts, and you can tinker with it and see the results. In my view, like notebooks give you that, but more for developers. And it's very underappreciated.
Yeah, I'm thinking I have kids in grade school, and all the lessons on code.org kind of run in the browser. They're evaluated in the browser, but they're all JavaScript because JavaScript can evaluate in the browser. Whereas now with this technology, I'm eager to see it go into those online tutorial spaces where now we can teach more of the kids more than just JavaScript.
Yeah, and that's what I would love to do if I were to do a second take on my book or on a book. Is like what I would really like is like a book which is actually a notebook, like where you can just execute the code, like tinker with it if you don't like it, and see what happens. Because that's where programming is a really nice way to do math. It's like it makes it live. It's like what if the number was 3 and not 2? What happens? You can just tinker with it and get a mental model of like this is what's going on. Change the input, look at the output, and you start to form a picture. Mm-hmm. But I think also even beyond learning, like we've been using it on projects with customers, and it's been a boon for testing whether our domain was on track. Like we wrote notebooks which were essentially describing the domain, and like doing some operations on it, and like give it to the customer and like have them run it and see like, is this what you meant? Is the result for the inventory giving the results you would be expecting or not? So it's a really good like discussion platform, which is because like you're not going to give a full project to build to a customer, right? Like it's not something a business user can do. Whereas like a notebook is like something which, if you're talking to somebody who's an analyst or like somebody who's a bit like close to the numbers, they can absolutely get it. And so that's a great discussion piece. And the benefit compared to something like Excel is like you have you can put your notebook on version control. So it's so you have your experiment and you can keep it, refine it. Whereas like everybody has seen things like Excel model, final version 3, all of this. Like it's terrible to keep track of what you're doing. Like notebooks give you, I think, a good hybrid between the power of code and the power of a scripting environment, or like the power of Excel.
Yeah. No, I can see that for sure. I'm actually brushing up on which I don't work in math every day, so I'm a little bit rusty, but I have my middle child is going into pre-algebra, and my oldest child is, in the advanced algebra in high school now. So I'm helping them and kind of brushing up. Now, that's not calculus or differential equations or any of the higher maths, but it's still fun.
Good luck. I wish you good luck in showing them that math can be actually really, really fun.
Yeah. Well, I think one of them tossed the idea of not enrolling into the advanced level of the math. And I said, no, you are going into the more challenging math class. It's not an option.
I approve of this message.
You mentioned Diff Sharp, which is really interesting. Are there any other math-related, just for the listeners, are there any other math-related libraries that you know about and are good that the listeners just should be aware of?
I think one of the old-timers there is still pretty good, and that's math.net. Like I've seen a lot of people doing home-baked recalculations of like variances, like all that type of stuff. And like math.net is surprisingly deep and like pretty good, like not necessarily high performance, but like is going to cover like a lot of ground.
Okay, good. Yeah, we'll include the link to that in the show notes. For sure.
I'm trying to think if like there are like other ones which are big, but like that's what pops in my mind at the moment.
Yeah, it looks like Looks like a pretty well-established, popular project, a lot of contributions.
And that's often something you want with a math project, because going back to the problem of like rounding, all of that is like getting 80% of the way there with an algorithm is easy, but like the 20 last percent is going to be pure hell. That's one place where having code which has been battle tested by a lot of people before is important.
Mm-hmm. Right. Awesome. Mathias, thank you so much for coming on the podcast. As we close up, is there anything else that we should plug? Any upcoming interesting conferences you think the listeners should be aware of, or events, or what should they do next if they're really intrigued by conversation on math and machine learning?
I don't know necessarily about the math and machine learning part, but I would say like one of the reasons I got into F#, like one part was the language itself, one part was the community. Mm-hmm. So I would say if people are interested to know more about F#, is like they should probably check the F# Software Foundation or the hashtag F# on Twitter. And people are like extremely responsive and like tend to be curious folks and pretty enthusiastic. And in general, it's not a plug, but so going to F# was an accident. Mm-hmm. But like the part I retained was, so what he taught me was like how much I thought I knew what programming was and how wrong I was. So I highly encourage people, like not necessarily to go to a specific place, but like make it your New Year resolution to take a different language on a different platform, ideally as different as possible from what you know, and see what other people are doing. And it's like you're going to realize that there is more than one way to skin a cat, and like there are many ways to actually write good code, and that will in general make you better in whatever language you use. So I would say like it's not a plug; it's more like be curious, go see what other communities are doing as well.
Yeah, good advice. Good advice for sure. Well, thanks so much again for coming on the show. This has been a very fantastic conversation.
It was very fun. Thank you for having me.
Oh, my pleasure. My pleasure. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.